Shear wall creation. To create a shear wall, click on the shear wall tool. A shear wall requires two insertion points or nodes. These insertion points are created by intersection of axes. Hence, 3 axes are required to create a wall. One longitudinal axis along the wall, and additional 2 other axes to create the start and the end nodes. The I end is the left end of the horizontal wall, or bottom end of a vertical wall. J is the right end of a horizontal wall, or upper end of a vertical wall. B is the width of the wall. E is the eccentricity, measure from the center of the wall to the longitudinal axis. The E value must be equals to or less than half the width of the wall. This means that the longitudinal axis must be located at the edge or within the wall width. Extension I and J is used to lengthen the wall slightly beyond the insertion point. However, this extension is meant to be small and preferably less than the width of the wall. The reason is that the extended part of the wall will not be able to support any members, example, beams or slabs. Let us now model some shear walls. Click on 2D view of Story 1 to make it active. Click on the shear wall icon in the Modeling tab. Let us use default width, eccentricity and extension. Click on the first intersection of axis, which will be the I node. A rubber band will appear. Click on the second node, which will be the J node. A shear wall will be created. Create 2 other shear walls as shown, which are connected to form the lift core. LEN, or length property, is exactly the same as column. The insertion options are a quick way to change the eccentricity of the wall with respect to the insertion axis. The insertion axes are all shown clearly here. Go to the Drop tab. The explanation for the wall drop panel is exactly the same as column drop panel. Go to the 3D tab. The plane will be listed if a plane element has been used to adjust the elevation of the wall. Del Z is the same as column, except the wall has I and J end for respective top and bottom nodes. By default, all values are 0, means the wall height and elevation will follow the story height. We recommend you do not adjust any of these values unless absolutely required. Support types and transfer member explanation is exactly the same as column. Wall model. This option affects both the analysis as well as design of walls. Click on the drop-down menu to choose. If you do not choose an option, it automatically goes to default, which will be mid-pier model. We will now explain in more detail these wall model type. Wall model type, mid-pier or FE shell. If you do not choose any option, by default, it will be mid-pier. Mid-pier idealization is single frame element at the center of the wall. A rigid beam is automatically created at the top of the wall, to support other members, such as beams and slabs. The deflection is constant and the same along the entire rigid beam length. Analysis time is fast and efficient as there are only 2 elements per wall. It is suitable for normal walls that starts from the foundation to superstructure. We recommend you always use this option unless there are special reason otherwise. In the FE shell model, the entire wall is meshed. As general guideline, the maximum mesh size should be story height divided by 4. In this model, the variation of stresses along the wall can be evaluated. The deflection may be different along the wall length, depending on the loadings. The analysis is obviously more since there are now numerous shells per wall in the analytical model. Particularly, the FE shell model should be used for long discontinuous walls supported by transfer beam. For merged shear walls, which are several walls that are combined, FE shell will be mandatory by default. Wall model type, basement wall, meshed. This enables special consideration for basement walls in seismic analysis and design, where the participation of the basement's mass in the dynamic analysis is varied. These results are run concurrently and combined in accordance with the relevant seismic code of practice. This is a unique feature which reduces the number of analytical models, which need to be considered for buildings with basements, to just one model running all analytical variations, in one analysis run. This wall type enables ProtaStructure to Use different cracked section properties as dictated by different seismic codes. Always use FE shell elements for these members in the building analysis. Utilize different design and detailing approach toward these walls. Wall model type, retrofit wall. A retrofit shear wall is similar to a RC regular shear wall, except that additional anchor, or dowel bar, are added, usually for seismic strengthening of an existing structural system. There will be an additional anchor, dowel bar design button in the interactive column design interface, which can be designed for retrofit. These walls are recognized by Prota details, and special dowel detailing can be produced, as shown below, in the shear wall elevation detail. Let us close the wall property. This means there are no changes to this wall, and we are accepting all the defaults. When a wall is selected, the Wall tab will automatically open at the top. This will expose functions that is only relevant to the walls. Alternatively, right-clicking will also expose these options. This applies to all elements, such as axis, columns, beams and slabs. We will now insert a wall opening. Select a wall, right-click, select Wall Opening Editor. Click Add, an opening will be added. You can then change the size and position of the opening. Then click OK, and the opening will be added. Please note that opening will not be designed for in the wall design. As such, if there is a large opening, example for lift door, it is recommended that you model separate shear walls, and join the walls by creating a beam between the walls. You can combine, or merge several walls into a single entity, for analysis and design. Hold down the Control key, and multiple select 3 walls. Right-click, choose Merge Vertical Members. When shear walls are merged in such a way, the reinforcement must be manually placed, using the Polyline Wall Editor. You can refer to Prota Help Center for more details. Let's unmerge the walls. Right-click, choose Unmerge Vertical Members.